All right, welcome back to pre-calculus. So we're going to continue our discussion of three systems or three equations and three unknowns here. This one looks a little bit more interesting than the other ones that we've done. So let's see what kind of trouble we can get into. Okay, so let me go ahead. I've shared my screen. So we'll go ahead and start looking at how to solve this equation and see what problems we run into here. Okay, so it looks like we have 3x. Okay, minus 2y, again, equals negative 16. Okay, we have 2y plus 3z equals minus 3. And it looks like we have a 3x, okay, minus 3z is equal to negative 9. Okay, and again, like I said, I always like to do this where I eliminate the x's out first, then eliminate the y's, and then usually you're left with just a z. That's just the way I like to do it. There is, if you like to eliminate z's and then work yourself back up to y's and then solve for x, that's fine. Again, it's the difference between do you prefer stripes or do you prefer polka dots? It doesn't matter. So what I'm going to do is I'm going to go ahead and multiply this third equation by, oh no, I don't have to multiply anything because that's a negative 3. Okay, so what I'm just going to do is just take equation 1 and add it to equation 2 and see what happens. So we have negative 3x minus 2y equals negative 16. We're not changing anything about equation 1. We're not going to change anything about equation 2. So we have 2y plus 3z is equal to minus 3. Not change anything. We're going to add equation 1 and equation 3 together. So I have negative 3x and a positive 3x. That's going to be 0. Okay, so negative 2y plus there's nothing there, so that's minus 2y. And then we have nothing, and then we have minus 3z. And then negative 16 and negative 9, that should be something like negative 27 or something like that, right? For $16 in debt, we borrow $9 more. We are now negative 27. Okay, so my new and improved equation 3 is going to be negative 2y minus 3z equals negative 27. Okay, so that's just to recap a little bit here for us. All right, now what I'm going to do is I want to get rid of my y's. Right, there's no more x's. Right, the x's are all gone. The x's are all gone. Okay, so what we're going to do is we're going to get rid of the y's. We're going to add equation 2 to equation 3. Okay, because that's the next step, is to get rid of the y's. And again, you could have done this in a slightly different manner, and it's just as right. Okay, so we're going to add equation 2 plus equation 3 and see what happens. So we have, there's no x's, 2 minus 2, so we're just going to have our, we're just going to have minus 3x minus 2y equals negative 16. We have 2y plus 3z is equal to minus 3. And then I have added these two together. So 2 and negative 2, that is 0. Oh, 3 and negative 3, that's also 0. And then we have 3 and negative 27, right? From $3 in debt, I have 27 more dollars I've lent. We have 0x plus 0y plus 0z's equals to negative 30. Is there any way that 0 times x, 0 times y, and 0 times z could possibly be negative 30? Whatever numbers you pick, what could we come up with here? And the truth is, like, there's not a damn thing that we could do about this. Okay, no matter which numbers we pick for x, y, or z, none of them are going to actually end up giving us an answer here. Okay, when this happens, we end up with, this is called inconsistent equation. Okay, there is no way for this third equation to be satisfied. We're just kind of done with it. Okay, so that's when that happens, you get something like 0x plus 0y plus 0z equals something that's not 0, then we get inconsistent equation. Now, what if it is 0? Then I think we're going to see that in another example, so I'll try to do one where we have another thing to do. Okay, I have a slightly different way of doing this than your book will represent, just because I've had the luxury of taking a class called linear algebra, and they do it a slightly different. They present the results in a slightly different way than what your book does. They're both correct. It's just that one of them leads to something that's a little bit easier to interpret later on versus the way your book is doing it. And they're both right. Okay, I'm not going to tell them like, hey, you're doing this wrong, because they're not. And if you do it the way the book does, you're fine. You're perfect. Okay, so in this case, we have inconsistent equations. So when I come over here and say the solution has no solution, okay, it's an inconsistent equation. Okay, and that's that. So we'll check, and then we'll move on to the rest of our lives here. Okay, so that's how you do a problem like that. When you get that 0x plus 0y plus 0z is equal to 0, then or equals something that's not 0, then we're going to end up with inconsistent equation. It's just something that cannot be true. If you end up with 0 equals 0, then you have infinitely many solutions. And like I said, we'll go into this is the equations are dependent, and we'll go through what that means, and we'll show you an example for those. Okay, so thank you for tuning in, and I will see you in the next video. Thank you.